So here in this problem, a RLC series circuit of 8 ohm resistance should be designated to have a bandwidth of 50 Hz. Determine values of L and C so that the system resonates at 250 Hz. So here there is a circuit, RLC series circuit, and in that resistance value is given as 8 ohms, and the circuit bandwidth is given as 50 Hz, and circuit resonates at 250 Hz. And here we are asked to find the value of L and C. So first we draw the diagram. So resistance, inductance and capacitance connected in series, and this combination is connected to a voltage source, and once you connect the circuit to a voltage source, there is a current in the circuit. So here resistance value is given and bandwidth of the circuit is given, so that is F2 minus F1 in Hertz. So 50 Hertz is the bandwidth, and resonate frequency. So circuit resonates at frequency 250 Hertz. So we are asked to find the value of L and the value of C. So here first let us find the value of omega R. So that is resonance frequency in radians per second. So we know resonance frequency in hertz, that is 250 hertz, but let us find that resonance frequency in radians per second. So that is 2 pi fr. Relation between omega r and fr is omega r equal to 2 pi fr, which is equals to 2 pi into fr is 250 hertz. So we get 1571 radians per second. So that is resonance frequency in radians per second. So quality factor. So here the given information is bandwidth and resonance frequency. So by using that two values, we can find the quality factor of the RLC circuit at resonance. So QR is equals to FR by bandwidth. So which is equals to 250 by 50, which is equal to 5. So quality factor of the circuit at resonance is 5. So unit is no unit for quality factor. So and also we know the relation between quality factor XL and R at resonance. So QR is equals to quality factor QR is equals to reactance offered by the inductor at resonance by resistance value. So which is equals to omega R L by R. So if you substitute the values, so QR is 5 and omega R is 1571, L is the unknown which we have to find, and R is given as 8 ohms. So from this, if you extract L, we get 25.5 millihenry. So similarly, we know quality factor at resonance. Once we know the XC and R, where XC is reactance offered by the capacitor, so which is equals to 1 by omega R C R. So which is equals, if we substitute the values, so QR is 5 and 1 by omega R value is 1571, C is unknown and the value of R is 8 ohms. So from this, if we extract C equal to 16 microfarad. So in this way, so we can find the unknowns L and C. So L is 25.5 millihenry and C capacitor value is 16 microfarad.